Right, question 1. For a bit of factorizing quadratics, you have done this, so I need things that multiply to give minus 3. If I'm multiplying, if this is a single coefficient of x, I can just have x and x. And then if I'm multiplying to give a minus number, I know that one is going to have to be positive and the other is going to have to be negative. So I can fill all that in to start with. Then if this is a prime number, then I'm in a great position because I know I've just got 3 and 1. And that's what I need to do. So I just need to work out which way round they go. And if I have minus 3 and plus 1, then it will get to minus 2 when I expand it out. But it asks me also to solve. So when this is equal to 0, this is a really key part of understanding what's going on. If my first bracket were 0, then it doesn't matter what this would be, your answer would still be 0, because anything times by 0 is 0. So if what value of x would make this bracket 0 when x is equal to minus 1? Because then minus 1 plus 1 would give me 0. This bracket would be 0. Minus 1 take away 3 would be minus 4, but it doesn't matter because 0 times by minus 4 would still be 0. So that's one solution, and the other solution is x equals 3, because that's what makes this bracket equal to 0. 3 minus 3 is 0. On this side I'll get 4, but 4 times by 0 is still going to be equal to 0. So we need to factorize and solve. So again here, I've got x, and I'm going to need one to be positive, the other negative. This time it's not a prime number, so I've got to think of the different factors of 6 that I can use. So it could be 3 and 2, which looks like it might make sense because this is 5. But actually it would never work because I can't get down as far as minus 5 using 3 and 2. So I have to go for 6 and 1. So if I'm on minus 6 there and plus 1 here, that's going to make that work, because it's going to be minus 6x and then plus 1x, which gives me minus 5x. So the values of x that make that work are x equals minus 1 again, and x equals 6 this time. Right, question 3, completing the square. A completed square form is something which I don't know if you guys have done before, but this is the way it works. I'm going to try to go as slowly as possible. I'm just going to take you through the skill, I think, rather than a deep explanation of it right now. So, if I halve this one here, this coefficient of x, 6, and then I make my bracket x plus 3, and what I'm going to do is I'm going to square that. So what that would give me, if I squared that out, that would give me, right, so I'm just going to show you here what's happening there. That's x plus 3 times by x plus 3, which is x squared plus 6x, right, because it's going to be plus, first will give me x squared, outer gives me plus 3x, inner gives me another plus 3x, and then last gives me plus 9. So it doesn't actually match up exactly to this here. So it's called a completed square because I need to complete this. I've got a square here, but I need to add something on to make it exactly identical. So in this case, I'm going to add on 11, because if I were to add on 11 to the plus 9, I would get plus 20, and that would make those equal to each other. So that's called a completed square form, and that is my answer there. What's down below is my workings for it. So I'm just looking at what I would need to add on to 9 so that this would be exactly the same as that. The same thing here. So I'm going to do x plus 2 squared. Now, that would give me x squared plus 4x plus 4. So it doesn't match up with this. So I need to make it match with that. So I'm on x squared plus 4x plus 4, but I need to make it match x squared plus 4x minus 2. So I need to take away 6. That then makes it match up. Yeah, because at the moment x plus 2 squared at the moment is giving me x squared plus 4x plus 4. I want to have x squared plus 4x minus 2, so I need to take away 6. Right, I think question 5 and 6 are quite similar to ones we've done before, so that's, yeah, so hopefully this one should be a bit easier. So we got out of 6, lowest common multiple, so I've got 2x out of 6 plus 3x out of 6 gives me 5x over 6. Lowest common multiple here, I've got 30, so times by 6, tops times by 6, 16, 12x. Tops times by 6, 12x. Take away, bottoms times by 5, tops times by 5, 5x gives me 8x over 30, or 4x over 15. 7. 12 take away 5 is 7. Good thinking. Yes. 7x, which just leaves it as 7x over 30. No simplification. Thank you. 12 take away 5. 7. Okay. Question 7. I'm going to expand this out. So each one of these, so I got root 3 times 2, which would give me 2 root 3, and root 3 times by root 3, which just gives me 3. Any square root times by itself gives you that number, right? Square root of 3 times by square root of 3 is 3. Square root of 5 times square root of 5 is 5, so on. Same deal here. I've got 5 root 2 plus 2. Question 9. I've got a bit of rearranging to do. So, I mean, at the moment it's not in the format which we like to have it, the gradient intercept format, y equals mx plus c. So I'm going to rearrange it so that it is in that format. So I'm going to add 4x to both sides. So that's going to give me 2y. I could write equals 2 plus 4x, but because I want to put it in the same format as we're used to seeing it with mx plus c, I'm going to write this as 4x plus 2. But I've not got it in the correct format yet because I've got 2y and I need to have just y. So if I divide by 2, I'll get y equals 2x plus 1. So the gradient of the line is 2. Because the gradient is this one here. Same thing here. I'm going to take away 6x from both sides. And I'm going to put it in the kind of y equals mx plus c form. So minus 6x plus 2. So then just divide by 3, divide by 3. So I've got y equals minus 2x plus 2/3. So the gradient of the line here, minus 2. Question 11. Simplify 2x squared y times by 3xy. So I'm going to multiply the coefficient. So that gives me 6. But then I'm going to use my index laws here. So x squared times x is x cubed. Y times by y is y squared. Question 12. Okay, let's just understand what this is talking about. Well, actually, this situation is the whole of that times by itself, isn't it? 3x cubed y squared times by 3x cubed y squared. So I can multiply my coefficient, that's going to give me 9, but now I need my index law, which is that if I'm timesing them, I can add them. If I've got it in a bracket, I can multiply it. So what I've got is 9x to the power 6, y to the power 4. Question 13. Express 124 as a product of primes. We've got a bit of a space issue here, so we're going to have to write nice and small. 124, I might just divide by 2 to begin with. So 62 times by 2, 2 is prime. I'm going to keep going, 31 times by 2. 31, is 31 prime? Yes, so we got 2 squared times 31. 48 as a product of primes. So 48, we've got 2 times by 24. 2 is prime. 24, I've got 2 times by 12. 12, I've got 4 times by 3. 4, I've got 2 times by 2. Here we go. 1, 2, 3, 4. 2 to the power 4 times by 3. The price is reduced from 800 to 480. Calculate the percentage change. So this is going to be the change over the original times by 100. There's multiple methods of doing this, but change over original times by 100 is 480 divided by 100. What's the change here? 800 take away 480, which is going to give me 320 over 800 times by 100. That's going to be my change. 32 divided by 80 gives me... What it gives me? 40%. Okay, price has increased from 800 to 920, so the change there is 120 over the original, which is 800, and I'm going to times that by 100, so we've got 15%. Okay, question 17. One significant figure is what we need to use to estimate. So always one significant figure. So I got 40 plus 60 over to one significant figure that will round up to 10. So we've got 100 over 10, which gives us 10. Again, we're going to round to one significant figure, so we're just going to use 10 here. So if you've gone for 12, actually one significant figure there is just going to be 10. So 10 squared take away 2 cubed. So that's going to be 100 take away 8, which gives me 92. Standard form. 1, 2, 3, 4, 5, 6, 7, 5.63 times 10 to the power 7. 1, 2, 3, 1.25 times 10 to the minus 3.